We don't have to redesign the whole circuit or the whole macro cell. If we can find exactly where the problem is, all you have to concentrate on is fix that problem, and your design will be robust. So let me show you an example of this. This is a yield sensitivity histogram plot in ADS, and what is shown here is this is a plot of the overall yield in the circuit relative to each component in the design. So here's input matching network R1. That's the component I'm going to look at. And notice the yield is flat here. There's no variation. That's telling me that if R1 goes plus or minus 10% on the x-axis, the yield doesn't change. So I know R1 in the input matching network is not a sensitive component. Okay, and this is looking at the total yield, the gain, the noise figure, and the S22 specs. You can take one out and it will update your yield relative to 2 specs or relative to 1 spec. You can even change your specs. Like I put here, noise figure spec is 1.85 dB. I can relax my spec. I can put 2 dB noise figure spec, and it automatically, by post-processing all the yield data, it will update this graph and tell you what would the yield be if you relax your spec or change your specs. This template is amazing. It really is very helpful to you. It gives you a lot of information. Now the same template, now we put output matching network R1. We just type the R1 for the output matching network here, and notice it is telling me that if R1 goes plus 5 or 10%, if it gets higher in value, the yield of the whole circuit with everything interacting together goes to 0. But if R1 goes into a lower value, the yield starts increasing. Wow, this is useful information. It is telling me that R1 is a sensitive component and you really want to reduce its value. You want to reduce its value and maybe control its tolerance. Maybe instead of plus or minus 10%, you want to make it plus or minus 5%. In Mimic, you can do this easily by making the width of the resistor wider. That minimizes or make the tolerance of the resistor lower. So this information is very useful. By putting every component in this template, you can see visually right away which components in the design is causing problems and which are not sensitive. The next tool is the design of experiment tool, which I mentioned before. In the design of experiment tool, which is very easy to use and very fast to access or to simulate and analyze your circuit with this design of experiment tool. In this plot here on the top, it's a Pareto chart of all the components in my design of experiment. For example, here, this is telling me my S22 spec, which is the y-axis here, the S22 spec, output matching network, the output matching S22, is affected mostly, like 55% of the variation in S22, of the sensitivity in S22, is caused by the output matching network C1, capacitor C1, followed by 35% of the variation by the width of the line, which is represented by EX here, the width of the line. So you can see from here that the dominant two components is this capacitor C1 and the width of the lines are the dominant components in S22 variation. But how much is that variation? Is it 0.1 dB or 10 dB? What is the absolute value? What is the actual variation? Then you can plot these effect plots, we call them, of the capacitor C1 variation and the width of the line variation. And here these plots are showing that the variation due to C1 is 2 dB, the blue curve. And the variation from the width of the line is 1.5 dB, which is the red curve. It's narrower, less variation. And notice also that design of experiments will help you find interactions. Here, it is telling me that 7% of the variation in S22 is caused by interactions between A and E. What is A and E? A is the output matching network R1 and E is the width of the line. So we have an interactions between these components that are even causing some variation in the S22. And this is very helpful because if you have very big interactions between two components, you must do something about it to isolate this interaction between these two components. And I have an example I can show you how the interactions is used in your design for manufacturing techniques. So I hope this was helpful introduction. This is the end of this section, section 1. In the next 3 short sections, we will show detailed information on each one of the DFM tools in ADS. I will show you detailed information on the sensitivity analysis, how it's used, on the yield and yield sensitivity histograms, and on the design of experiments tool, DOE. Thank you very much for listening.